Okay, so, assuming I haven't fudged up the audio or something, hello, young bum. So I'm just gonna be showing you how to solve the maths problem that wasted my lunchtime. So, a quick review of the question. I didn't draw something. So, there is a circle and a square. The circle has a radius of 2, and the square has a radius of 2. They overlap such that this area and this area are the same. Okay? And the distance from from here to the center is x. Now this is a perpendicular bisector of this side, which means that this is a right angle. And this is equal to that. So, let's get rid of that. And let's start solving the question. So, what you have to first do is draw a triangle. So what you have to do is link up these 2 points, and then okay, no, I didn't mean to do that, but then you have to join them up to the... I really don't know why this software is so bad. It's just the only thing I have, so... You link up the corners to the center. And voila, you have a triangle. So what now? Okay. It's a pretty bad drawn triangle, but what do we know about this triangle? What are the lengths of the sides? Now, because this is the same, from here to here, is the same as the width, that means that this must be 2 centimeters. I couldn't bother writing centimeters. And what about from here to here? Well, that's just the same as the radius, because radius, so that's 2. And that means this is also 2. So boom, we just discovered an equilateral triangle. That's cool. So what now? Well, an equilateral triangle always has angles of 60 degrees. I hope you know that. Yeah, you probably do. Anyway, that is a poorly drawn 60 degrees, but you get the idea. So, now what? Well, we want to know the area of this and this. So, the square has lengths of 2 sides. Yeah, lengths of 2, right? The sides. So that means that the whole area is 4, which means that this part is 2, and this part is 2. So this part is 2, and this part is 2. Okay. So, we know that this sort of rectangle that I'm going to just trace badly. Oh, okay. Cool, but has 2. This rectangle, there's a rectangle, wait, how do I explain this? There's a rectangle here, and then there's also an arc here, and together they make an area of 2. Now, why am I telling you this? Because to figure out how long it is from here to here, we need to know how big the segment is, which I'm going to just outline here. Boom. We need to know the size of the segment, the area of the segment. How do you do that? Well, you can examine that the segment, which can be drawn like this. What? No. Is like a pizza slice, which I'm going to outline, subtract the triangle. So we have to do pizza slice, subtract triangle. Sorry for my terrible drawing. So the pizza slice has an angle of 60 degrees. What that means for us is that we know the area of the pizza slice because 60 degrees is a sixth of a circle. So therefore, the pizza slice is a sixth of the whole thing. So the circle has a radius of 2, so pi r squared is 4 pi, and then divide that by 6, we get the area of the pizza slice, which we can simplify down. 2 pi over 3. Nice. Now what about the triangle? Now, assuming that you've learned about the okay, I'm going to explain it to you. Even though you've probably already learnt it, a Pythagorean theorem, I'm just going to assume you know this, okay? A squared plus B squared equals C squared in a right angle triangle. So, and we have 2 right angle triangles here, so that's great if you split an equilateral triangle in 2. Anyway, so we know how long C is. C is 2. And A is just the base split in half. So A must be 1. And if A squared plus B squared is C squared, that means that C squared minus A squared is B squared. So what that would leave us is us knowing that 2 squared minus 1 squared equals B squared. 2 squared minus 1 squared is 4 minus 1, which equals 3. So 3 is B squared, which means that the square root of 3 is B. So let's go back to our diagram and let's just clean it up, as we don't need all these 2's. And this gross angle bit. Yuck. Damn, I accidentally rubbed out the X. Place the X. So we know that from here to here is square root of 3, and now we need to work out the area of the triangle to find the area of the segment. So, wait, this is such terrible software, but it's the only thing I have. We know that the height is root 3, so we need to times it by the base, which is 2, and then we need to halve it to find the area of the triangle, which will just still leave us with root 3 for the area of the triangle. So, if the area of the triangle is square root of 3, then the segment, I'm just going to highlight again in case you forgot, this bit, that bit is just the pizza slice, which we find out to be 2 pi over 3, subtract root 3. So what do we know? So what do we do now? Now that we found the segment, we can find out the rectangle. I'm just going to do the rectangle again. Boom. You see that rectangle? We can figure it out. I'm getting rid of the rectangle. We know that the segment plus the rectangle equals 2 centimeters squared. So, therefore, to find the rectangle, we do this and take it from 2. We can write that out as 2 minus 2 pi over 3 plus root 3. It's plus root 3 because 2 minuses make a plus. So what now? Well, I'll tell you what now. We need to know the length from this point to this point. So the way to do that is because the width is 2, because each side of the square is 2, blah, blah, blah. Then to find the length of that part, then what we have to do is just halve it. Halve everything. If you do that, then what we get is 1 minus pi over 3 plus root 3 over 2. Boom, we're nearly done. Now why do I keep drawing squiggles instead of zooming? We know from here to here is root 3. So to find x, all we have to do is root 3 minus this. Okay, to find x. So here, root 3 minus 1 plus pi over 3 minus root 3 over 2. And then, because root 3 minus root 3 over 2 is just root 3 over 2, then the final answer is x equals root 3 over 2 plus pi over 3 minus 1, and we solved it. Yay! I'm probably going to edit in a louder cheer, but we solved it. So yeah.